So far we know that I is the symbol we're using for the square root of -1. And we've seen that I squared then is the square root of -1 times the square root of -1, or just plain -1. Let's go on and look at what I cubed should be. Well, I cubed is I squared times I. And that's -1 times I. So we're just going to say that I cubed is the same as the opposite of I. I cubed is the opposite of I. Now let's check out I to the 4th. I to the 4th we could think of as I squared squared. If we squared I squared, we'd get I squared is -1. So now we have -1 squared, and -1 times -1 is +1. Now the fact that I to the 4th is -1 is very significant, because the next time we go to another power, I to the 5th, all we have to do is say that this is I to the 4th times I, and I to the 4th times I is just 1 times I, so I to the 5th is the same as I. We're going to start all over again. There are really only 4 different powers of I. We have I that's the square root of -1. We have I squared is -1. We have I cubed that is -I. And we have I to the 4th, which is +1. All other powers simplify back into one of these 4. Let's see how we could play that out and try to find some pattern. I to the 6th would be I to the 4th times I squared, which would be 1 times -1, so it's -1. It's just like I squared. So the secret looks like we want to find out about 4s. Okay? If we want to do I to the 15th power, we could say that was I to the 4th, I to the 4th. Now we've got 4 plus 4, adding exponents is 8, and 4 more is 12, and 3 more makes 15. So we have 1 times 1 times 1 is all 1 equals I cubed, which is -I. Now essentially what we're doing here is trying to figure out how many sets of 4 powers are in the original power, and then looking at the remainder. So we could jump ahead now and we could say, well, that gives me the capability of figuring things out a little differently. If I wanted I to the, say, 50th power, I would take 50 and I'd say, how many 4s are in 50? Well, that's a division problem. How many 4s are in 50? So your answer comes out to be, well, there are 12 4s. 50 over 4 is 12 with a remainder of 2. So there are 12 of these I to the 4th factors, all of which are 1, and I wind up with the remainder. It's just like I squared, which is -1, and I'm finished. What's the process? Look at the exponent, divide it by 4, use the remainder to put you into one of these. There are just a couple of little tricky things along the way. You might consider, well, what would I to the 0 be? Well, there's 2 ways to think about this. First of all, anything to the 0 power has always been 1. And unless something different happens now that we've gone to imaginary numbers, we could make an argument that it should still be 1. Otherwise, we could say, well, let's use the process again. If we take 0 and divide it by 4, and we get a remainder of 0, what does that mean? It means it's evenly divisible by 4. So there's a whole number of power 4 factors. So they all must be 1s. So this has got to be 1. So remember also that even I to the 0 power is still positive 1. So in this section, we've seen how to multiply complex numbers in a plus bi form by using FOIL. We've seen how dividing complex numbers looks a lot like rationalizing an irrational denominator with 2 terms. And we've seen that there are really only 4 powers of this strange new number, I, the square root of negative 1, because they keep cycling around and around. That's called a periodic function. Okay? So you should be able to find the equivalence of any power of I, as well as do the multiplication and division.